Hello, I'm your classmate, Batran. In this final project for this mass media class, I want to recreate my lectures for my National Science Honor Society class, or society. And it's on the shape of time. So, what is time? Can we actually measure it with a meter stick, like the same way we do with space, or we drop a rock inside a volume beaker and see how much the water rises? Well, let's kind of find out now. The first model was created by Sir Isaac Newton, and what he said that time exists in both direction, positive and negative infinity, and there is no endpoint or beginning of time. And he said that, well, when time and space does exist, they do not affect an event. The same way you could slip on a banana peel today, right now, right here, where you watch this, but it doesn't mean you could not slip on a different banana peel somewhere else in a different time. The event is you can slip on the banana, but time and space is affected. And this is a different model than what we already believe, that a train track, time can exist in the negative direction and positive direction, and possibly able to branch off somewhere and loop back to where it began. Let's move on. And this is Sir Isaac Newton model. When time and space in the background, the event is the train moving forward. And then a guy named Immanuel Kant, he's a German thinker, said that if we exist infinity in the past, why something should happen already happened. Like when there's a chance that a gorilla could fly from the sky and fall on top of you. That is a very, very small chance. It never means zero. So if the infinity time, would there at least one time the gorilla be on top of you? And also he said that if time exists infinitely, why haven't we reached thermal equilibrium where all things have the same temperature and we all dead? And then our good friend Albert Einstein came in with this theory. He said that Sir Isaac Newton sucked. There is a beginning and there's an end. In general theory of relativity, nothing is absolute. Everything exists in relationship with each other at this thing. There's the grid in the background is space-time. Three-dimensional space, length, width, and height, with one more extra dimension of time make this grid. The platform, like a piece of paper, is space. How deep it goes is time. The more curved it is, the less time you have. And something very heavy, very massive, could make a dance in space-time, and other objects would curl around it. You can imagine like a blanket. You put a bowling ball on your blanket, there will be a dance. And you try to throw a marble in a straight line, it will curve around the bowling ball. And to exist in this space-time, the object will be too large, too heavy in the bowling ball, something like the bowling ball. It will fall through the space-time grid. So the matter that make up this ball or this arbitrary planet transfer into energy and hold it up. And because of this, we have the equation equal mc squared, where energy could transfer into matter and matter could go to energy. Because of this theory, time have a beginning and an end, because it could be curved, it could be stopped, it could be slowed down. But the universe have to be at one point in the past or one point in the future have an infinite amount of density in it. This point called singularity in its personal mind. And then some Russian guy came in and say, okay, if there's a point where all matter exists, all matter must miss when they exist. When two planets like this attract each other, when they attract, they miss, and the universe expand from that one point. And then Stephen Hawking and his good friend Roger Penrose come in, say that space-time curved by a massive object like this, but light could also curve by massive object because of lost object or have positive energy, and positive energy attract light. So when you shoot two light at a curvature space-time, the light will curve around that object and somewhere in the future would meet at one point. And this is the past light cone theory, or you can say it's a model. He said that if you look at a light from the past, the further you go down, the earlier time you can see, which means you can imagine it's at the sun. The light from the sun reaches us in 8 minutes. So whenever you observe the sun, we actually observe the sun 8 minutes before that. So the further you go away from the light, instead of going direction of the light when it's going, the further you go away, the more time you can see the past. And because of this model, he created a bigger model for the whole universe. And I would say, guess what it's appeared like? It's appeared like model, where we is right here observing the universe, the galaxy, and the further you go down from it, you can observe the galaxy or the universe at earlier time. And because at this point, so much mass in a little space, not one point, one plane. That's the light curve again and reach singularity, or the beginning of time, the Big Bang. But this place, the density is so high, the time is infinite, and it could be stopped. And that is the end of this lecture. That's my very quick recreation of the lecture I gave. Hope you kind of understand a little bit more about astrophysics and how time came at its believed to be today. And yes, I do wear this hat with a reindeer and a Christmas tree on it during that lecture. So, if anything else, you can just try to reach out from the comment section. Thank you.